Okay, finally, the last thing I want to talk about with regards to these permutations, combinations is permutations, but with repetition. And here's what I mean by that. What if we're determining the number of permutations with this group of objects, and some of them are appearing more than once? Okay, so we do care about the order, but what's happening is there's objects that I'm picking from. There's some of them that occur more than one time in there. So the word Mississippi, for example, I could pick an M first, and then I could pick S, but there's 4 S's I could pick from, and they would all be the same result. It would still give me S as my second choice, and then let's say I get a P the third time. Okay, so the order matters, but now what doesn't matter is which S I pick, or which of the 2 P letters I pick. Those are going to create a lot of repetition in my results. Okay, so the adjustment we have to make is what we'll talk about next. And here's, again, what we're looking at is the S. The order of the S's doesn't really matter. So here's our adjusted formula. Okay, I've got n factorial, which is n is the number of letters in the Mississippi, or letters we're choosing from. And now I've got these k factorials in the denominator that we're dividing, and those k's are the numbers of repetition of each letter that occurs. So for every duplicate that you have more than one of, you have to take that factorial and divide it to reduce our number of possible outcomes. So the I, for example, shows up 4 times, so I have to divide by 4 factorial. S occurs 4 times, I have to divide by 4 factorial again. P shows up twice, so I have to reduce my number of possible permutations by 2 factorial. So every time there's a duplicate or more than one of something, that's going to bring down my possible number of permutations by the factorial of that. So instead of 11 factorial, it's going to be divided by those amounts, and in this case the result would be 34,650.